So when given a problem involving specific heat or a temperature change, we have to take a couple of things into consideration. But before we do that, we really want to start off the problem by going through our normal problem-solving algorithm or the normal steps that we have to getting to our solution. So step one is always to read the problem, annotate it to get the important piece of information, and then we want to assign any important piece of information to variables that we think that they go with. So our problem that we have here says you were given a 7.40 gram sample of liquid water at 17 degrees Celsius. How much heat would be required to increase the water's temperature to 55 degrees Celsius? So as I go through, I'm going to look and I'm going to try and pull out important pieces of information. So you're given a 7.4 gram sample of liquid water. This 7.4 gram, that's going to be important, and it's also important to note that it's a sample of liquid water. Because we know that things like specific heat are dependent on state. That means that liquid might have a different specific heat than solid, which might have a different specific heat than gas. Continuing on, we see that it's at 17 degrees Celsius to begin with, and we're going to heat it up, the water, it's going to increase to 55 degrees Celsius. And then the fundamental question it's asking us to solve is how much heat. That's what we're looking for. We're looking to solve for how much heat is required, how much heat is necessary to make this happen. So now that I've annotated the problem, the next thing I want to do is I want to pull out all of our important pieces of information. I want to assign them to a variable. That way it'll be easier for us to kind of just drop them into our equation and to plug them into the correct location. So you're given 7.4 grams. So we've got this 7.4 gram number. So we have to decide what that is. So we know that we have a variety of options. It can be a temperature, it can be a specific heat, it could be an energy value, or it can be a mass. So we have to think through and try and figure out what grams actually measure. So things like grams or kilograms or things like that actually measure mass. So anytime I see the variable gram or kilogram, I'm going to assign it to the variable m because m means mass for us. Continuing on, the next thing I see is that we have this 17 degrees Celsius value. So 17 degrees Celsius is a temperature. We just have to decide whether that's the starting temperature or the ending temperature. Because one of the other important pieces of information that they give us is that 55 degrees Celsius. So we have two temperatures that are given. So we have to decide which one is our ending temperature and which one's our starting temperature. So reading through the problem, it says you are given a sample of water at 17 degrees Celsius. That means that's where it's starting at, which means that it must be ending at 55 degrees Celsius. If we go a little bit further, we know that if we have a temperature change, that means we want to use the formula that we have that involves temperature, which means we have to also find the specific heat value. We have to find that S value. So now here's where that state becomes really important. So as we're looking through, we want to be able to make sure that we can find our specific heat for water. Now notice on this list of specific heat values, water shows up in three different states. We have solid water, we have water vapor, and we have liquid water. The problem says that we have liquid water at 17 degrees Celsius. That means that we're going to be using this specific heat value down here, that 4.18 number. So now we can transfer that over to our list of information. It's a constant that we definitely know is going to be something we're going to use. And we'll make sure that we bring our units with us. The table says that that's in joules per gram degrees Celsius, so I'll write that over here as well. After we've found our specific heat value, the next thing we want to do is we want to put everything into our equation. So recall that this is our equation. Q is equal to the mass of our substance times the specific heat value times that change in temperature, that final temperature minus initial temperature. This problem asks us how much heat, so it's asking us for what the quantity of heat needed is going to be. So we're going to solve for Q in this problem, which means we'll leave it as that Q value because we don't know what it is. That's what we're solving for. We'll plug in the mass value that we have, which is that 7.4 number. The equation then tells us we're going to be multiplying by the specific heat value. So we'll plug that value in there. And then we're going to multiply by the quantity of the final temperature minus the initial temperature. Now looking at this equation, I'm going to do whatever math I can do right away just to begin with. So looking at this one, I can see that my order of operations says that I should do whatever is in parentheses first, which means I should take this 55 degrees and subtract 17 degrees off, which means my next line of algebra should show that I've taken that step. So we'll take everything with us still because we haven't changed anything fundamental about the problem. We still have all of these ideas with us. 55 minus 17 is 38 degrees Celsius. So now we can take all of these numbers, and the problem says we're going to multiply them all together, which means that my Q value should be along the lines and should be pretty close to an answer of 1,175 and 0.416 joules. So again, we took our mass and we multiplied by the specific heat value, so my gram term is going to drop out. And then we took that and we multiplied by our temperature term, so my Celsius term drops out. We're only left with joules at the end. So our unit for Q, or the unit for our quantity of heat, is going to be joules. Realistically, any problem that we encounter is going to have a very similar setup. We're going to annotate, we're going to list out all our variables that we have, and we're going to plug it into the equation that we want to use. As long as we can do this, list out our variables, and we can plug them into the correct location, the algebra should take care of itself.